Hey guys, we're going to be talking today about systems of equations. Again, another section where we're hoping it's a little bit more review than it is new material. What we're basically doing this chapter, if you guys haven't figured out, is we're trying to connect some geometry concepts back to your algebra concepts. Algebra is that universal link that kind of connects all these different math subjects from geometry to your lower level mathematics all the way up to college mathematics. So definitely want to review some of those algebraic concepts. System of equations, where we'll be at today. So first thing we're going to be talking about are the types of solutions that you can have in the systems of equations. You can arrive at the answer of one solution, no solution, or infinitely many solutions. Visually, this is what it will look like. If I have two lines that have different slopes, well, eventually those lines are going to intersect. Where they would intersect is the one solution. It's the one point that satisfies the equation for both of these lines. You could have no solution. That means that they never intersect. Obviously, this would imply that the lines are parallel. I mean, they have equal slopes. They're also going to have different y-intercepts, because if they had the same y-intercept and equal slopes, then they're the same line. And if two lines are exactly the same, well, they share every single point. So there's infinitely many solutions. So one, none, or infinite. Looking at the equation of the lines, you can tell if it has one, none, or infinite. Again, my one category. Each of these systems consists of lines that have different slopes. Therefore, they're going to intersect somewhere. Where they intersect? Well, we got to do a little bit of math for that. But they're going to intersect somewhere. That's a guarantee. No solution. Notice that in each of these two boxes, we have a set of parallel lines. Same slope, same slope, same slope, same slope. Right? Now, because they have different y-intercepts, we can still say that they are different lines, but they will never intersect with one another because they are parallel. Lastly, we got infinitely many solutions. Now, even though they're not the same exact equation, these are the same line. These equations are equivalent to one another. Very easy example is if I divide the first equation by 2 in this first line, I would have the same exact equation as below. Likewise, if I had solved this first equation for y, I would have that same equation as the one underneath it. So even though they look a little different, they are in fact the same solution. So looking at some examples down here, let's see how many solutions exist for these systems. Well, again, you may want to pause the video now, give yourself a time to challenge yourself to answer on your own, then hit play to confirm. Same slope, different y-intercept. That implies those lines are parallel. We can put a little parallel symbol. Parallel, not 11. Over here, I notice 2x plus 8. Well, even though it's written differently, 4 over 2 is 2. So these are the same exact line. They have the same exact. If they are the same exact line, infinite solutions. Over here, you can do process of elimination because you guys know my style by now. But if I solve this equation for y, this first one, I have the equation of y equals 3x minus 6. This has different slopes, so therefore one solution. Okay? Now we talk about the types of solutions or how many solutions we can have. Let's talk about how you actually find those solutions. One technique is graphing. We're not really spending a lot of time on graphing, but graphing is you graph each line and you see, hey, where they hit one another. Now, if you look at your notes, the notes are designed to highlight the fact that this is not the best strategy. I mean, is that 2.6, 2.5, 2.68? I don't know. So it's very difficult, it's inaccurate than to just guess what that point may be. Technique number 2 is substitution. Now this one and elimination, we're going to be using it a lot. So substitution, very accurate, relies more on your algebraic skills. However, if I ever got a coefficient other than 1, it becomes a little tricky. Well, let's get into some examples of substitution. Then we can talk about some of his weaknesses on our next section. So I notice over here, this first equation is y equals. Y is equal to something. If you know something is equal to something, you can substitute that amount for that variable, right? If y is equal to 3x plus 8, then that second equation can be rewritten as 3x plus 8 in the place of y. And we do this because obviously now I have only one variable in my equation, just x's now, so we can solve the equation. we rewrite this equation as 5x plus 8 equals 2. And from here, we can solve. Solving this equation, we're going to subtract 8 from the left and right side and divide by 5. We get x, little screen, x equals negative 6/5. Now, in order to determine what y is equal to, because our solution should be an ordered pair, we're going to take this answer and substitute back into either one of the equations. Doesn't matter which one. I'll do that first one. Y equals 3, negative 6 over 5, replaces x, and we have our equation here. We can get negative 18 over 5 plus 8. Then we can simplify this amount as well and make it into a improper fraction or a mixed number. Let's just say we want to make this into an improper fraction. We would come out to the value of 22 over 5. All right? Now, this other substitution problem we have over here might require us to solve for a variable first. The variable is by itself is x. Now, it's not completely by itself, so that is 1, but it's the only variable that has a coefficient of 1. So I'm going to subtract 1 from each side. Noticing now, I have a solved equation for x. Using what x is equal to, we can substitute that into the other equation. So let's substitute 5y minus 1 in for x. 2, 5y minus 1 plus 3y equals 1. Alright, from here, you would solve for y and then back substitute in for x. I'm going to leave that one for you guys to finish off if you want. Our last method that we're going to talk about is the elimination method. Alright, the elimination method. Now, it is accurate, and this one is the one we want to use when substitution isn't really our go-to choice. And that occurs when we have variables that, well, none of the variables are isolated to have a coefficient of 1. There's no coefficient of 1 in these examples. So elimination, as you guys recall, our goal is to eliminate a variable. So we're going to write our equation in stacked format. Our goal is to combine these two equations and ideally eliminate a variable. Well, if we add these equations together, notice I have a negative 3y and a 3y. Adding them together, we would get 0y, which would eliminate that variable, leaving us with 6x equals 18 and x equaling 3. Now we can use the fact that x equals 3 and substitute into either one of our original equations to solve for the y variable. So if I use that first equation, we say 2 times 3 minus